Good morning, everybody. I'm Scott Fryer, and if you caught the previous panel on security audits, I'm going to provide a bit more of a detailed view of the Adoptium Temurin experience of the security audit, slightly more detail into the process we went through, and some kind of insights and ultimately the conclusions we came to at the end of the process. So, before we get started, a bit about me. I joined Red Hat and work full-time on the Adoptium project about 2.5 years ago. I'm not from an open source background prior to that. I've worked in the utility sector and financial services. I've had a lot of dealings with meeting regulatory compliance demands, both in the deregulation of utilities and in financial services. My main focus has been in source code control, security, DevOps, and that sphere, and ensuring tools and processes meet the regulatory requirements in those backgrounds. So joining this project was kind of an extension to bring those skills into Adoptium. So the Eclipse Adoptium project, if you don't know what it is the top-level project looked after by the Eclipse Foundation. And at Adoptium, I largely work within the Temurin JDK distribution. I think it's one of the most downloaded open JDK distributions, and I think it's possibly, according to one survey at least, the second most popular after Oracle's JDK. So, middle of last year, the Eclipse Foundation engaged OSTIF to appoint an auditor to perform a security audit of our key software supply chain. The software supply chain work we've been doing at Adoptium for the 2.5 years I've been there is designed around meeting the US government regulatory requirements, NIST SSDF, SALSA, which is Eclipse Foundation, preferred security regulatory framework, and obviously with the looming CRA, most of that work should hopefully be relevant to that once we have a final definition about what we're meant to meet that. So performing an audit to make sure all of the things we're putting in place to meet all of those regulatory frameworks seemed like a kind of the next step to validate the work we've done. So the audit journey looked a little bit like this. So we had a scoping period, an analysis period, actions and reporting. I don't think that's a particularly unusual process. So we started off once the auditor, a company called Trail of Bits, had been appointed. We had a number of scoping meetings to both with them and internally to identify all of those key GitHub repositories that all our source code is in particular relating to how we build our development infrastructure, our build infrastructure, how we then build our JDKs and how we process those through into a distribution. So identifying all of the key repositories involved in that process from source code to deliverable was kind of the earliest part of that. And then we also identified the goals, what the coverage was going to be, what the key area of focus should be, where the vulnerabilities would likely be focused. So we completed the scope. We then left the auditor to do the analysis, pretty much. So they conducted a very detailed review of all of those GitHub repos. There's reports and things available with a full list of everything they did, and they evaluated our documentation, they evaluated our code base, and there was a number of back and forth conversations and meetings during that analysis period where they had to seek clarification about particularly abstract or complex areas of the code, and where findings were potentially ambiguous in some cases. Discussions were had about whether they were actually a risk or there by design. So that analysis phase took several weeks. And so during that period and flowing into the third period, the action, where issues were found, they were discussed and remediated. In some cases, relatively simple, like securing downloads, checks on validation. Other things may have been more process-related and ensuring our infrastructure access security policies are solid and correct. And again, normally, we implement fixes, we test fixes, and Another outcome was the improvement of future processes. So Trail of Bits used a tool called SemGrep, which is an open source tool, I believe, and a set of rules which performs dynamic code analysis. So again, we implemented ongoing GitHub action checks on PRs to ensure that things that had been fixed weren't being unfixed by developers. So your PR doesn't get merged unless all the checks passed. Putting in an audit action to ensure that that's staying constant is a good ongoing improvement. And lastly, we're an open source project. Everything we do is open and in the public. So again, we have reports, summarized all the findings, summarized all the fixes we've made. Trail of Bits and the auditor produced a report, and the Adoptium project itself produced a response to that report to highlight all the work that had been done. And again, that was shared by the community, and we always value the community's input and value in these things. So the results and the value, with lots of fixes done very quickly in a short period of time, process improvements, and we could demonstrate that we'd made all these improvements. We've got the whole end-to-end value of the project. And the value to us as a project, we have an improved security posture. It's demonstratably improved, where we can say we've done this audit, this is what they found, this is all they found, this is what we fixed. We are now likely to be more compliant with any relevant regulation, and our consumers should have more confidence that our JDK distribution is even more secure. So the particular bits of our repositories and our code base and our process that we wanted to really ensure. So, and this ties into the regulatory frameworks quite well. So particularly how and where data is stored. There's a lot of regulation about how and where you store and process data. So asking the auditors to validate, again, that we think our data is where it is. It was a key part. Our authentication methods and mechanisms underpins a lot of security. If your fundamental authentication strategies aren't good, you have a basic fundamental problem in the rest of your security model. How our internal systems authenticate to each other. Thinking back to the SolarWinds, if one server is compromised, potentially they're all compromised. So again, validating that all of those things. How does user input flow through the system? We have a number of jobs and processes that allow user interaction, selecting test suites to run, things like that. So again, ensuring that they're not vulnerable to command injection and things like that was another key area that we asked the auditors to look at. How we manage our infrastructure, again, how we manage access. All of our infrastructure is donated by organizations, companies like Hetzner, Azure, OSU, OSL donate a lot of machines. Because all of our infrastructure is public, it's exposed to the world, there's an element of risk introduced there, that it's important that we have good management practices in for how we manage our infrastructure. How we use cryptography. All of our binaries are cryptographically signed, GPG key signing, elements like that, and ensuring that we use checksums and cryptography methods across our development, build, distribution process was vital. And again, how we download and install software. Building of a JDK has several external dependencies on various libraries. So again, ensuring that those are secure and we're not importing third-party liabilities was another key area. And the types of users and privileged parties that have access to the system. We aim for a zero root access and a zero password access strategy. In the real world, it's not entirely possible to do that across the board. So where we have exceptions to those, validating that we don't violate those in any noticeable way. So this was the kind of the focus of what we asked the auditors, where they should really focus their efforts. So this is really getting into the nitty-gritty, but this is how Trail of Bits conducted their audit. So first off, they did a static analysis coverage using this SEMGREP tool. So this looked for connections to endpoints with and without encryption, any connections where SSL verification wasn't in place, because obviously middleman attacks are entirely possible, disabling of any authenticity verification mechanisms, host name or host key verification being disabled. All of these kind of critical, what would be critical vulnerabilities, can be analyzed and found using SEMGREP. It's a great tool, highly recommend taking a look. And it found enough that we warranted an ongoing permanent check across our code base that SEMGREP would run on every PR to ensure that no more vulnerabilities of that type would be introduced. They also conducted a manual review of the code base and our documentation. So again, this was looking for the authentication bugs, the command injection, and that kind of vulnerability, and where security features were disabled. And again, there's an element of technical debt there, so where they found a couple of those things, it was a case of, in one case, de-supporting an operating system which is no longer valid to use because it doesn't support secure verification. So just de-support that, throw all the hardware out. And then they also analyzed the final binary JDK distributions we produce. So again, they use a tool called CheckSec. It's not one that I'm vastly familiar with, but again, it looked for things that the binary is doing in a bunch of ways that are potentially vulnerable. And again, the coverage limitations, our code base is significantly huge. A lot of it is inherited from the upstream OpenJDK source code, so they didn't necessarily conduct detailed verifications of vulnerabilities in our dependencies, external libraries that the OpenJDK relies on to build. We validate that we're pulling in the correct versions and checksums match, but not necessarily that they have their vulnerabilities. So there are limits to everything. With an infinite amount of time, I'm sure all of this could be done, but in 2 weeks, I think what we covered was sufficient to give us a greater degree. We have other tools in place now to hopefully allay a lot of those third-party dependency vulnerabilities. So, some of the sample findings give you a bit of a taste of the stuff that came out, save you reading the report at least today. So, in one case, somebody had renamed the Dependabot workflow. So Dependabot was no longer running on one of our repositories. So fairly easy fix. Re-enable that Dependabot workflow, bring all our dependencies back up to date. Not quite sure why it got disabled, but again, it was a simple fix and relatively easy to put right. So, but again, we now have the overhead of managing Dependabot's updates in case it breaks anything and things like that, but it's still a notable improvement. And there's the PR that we raised to re-enable Dependabot on that repository. And just there on that slide, again, the whole bunch of Dependabot doing its things after the event to bring everything back up to date. Second one, we've got an incorrectly pinned GitHub workflow. It's one I see quite a lot in many repositories where you're calling a GitHub action from a workflow that is not pinned to a SHA. Pinning to a version number is not sufficiently secure. You should always pin to a SHA of a GitHub action. I'm led to believe, from people that know better than me, that it is possible to relabel a dependency with the same label and inject a vulnerable module in. So pinning to a SHA is definitively the better way. And again, where they found this example, we went through and pinned to SHAs of validated versions of those dependent actions. Disabled signature verification. This was a particular problem on OpenSUSE 12, which was end of life a number of years ago. So again, the fix was to remove our support for OpenSUSE 12. We support later versions, and we certainly do SLES 15. And at some point, we will re-implement OpenSUSE support with Leap if there's a demand for it. Nobody's screamed for it yet, but if they do, we'll put the support back in. But removing that vulnerability completely was the right solution in this case. So again, this is the PR, the code changes we made to do that. So, conclusions. What did we really take away from that? One, our security posture was probably better than I thought it was going to be with an audit. I come from a paranoia background, so I always expect everything to be the worst. It wasn't as bad as all of that. The findings revealed that although we'd got some vulnerabilities, they were either difficult to exploit or not particularly high risk. So it validates a lot of the other work we'd done. So it validates that a lot of our practices, particularly around our infrastructure security, are strong. We did identify a bunch of areas for improvements, making sure things are pinned, putting in future checks, and it identified things like configuration gaps, developer knowledge. So again, we now have areas of improvement and areas we can improve across the project, and involving everybody in the project with these security discussions hopefully means everybody is slightly more aware, all of our developers are slightly more aware of their obligations to follow a secure development method. Again, an awareness of emerging threats. If you work in the security field, this is kind of a permanent, ongoing hobby. New threats emerge every 15 seconds or less. Staying on top of that is a full-time job, or 2 full-time jobs for everybody. And having an auditor perhaps covers some gaps there, that tactics and things that you may miss, again, you are highlighted and brought to attention, and if you know the threats, you can act to mitigate them. Collaboration learning. We're an open source project. We welcome contributors from everywhere, so collaborating with an external third party, getting a fresh set of eyes, and involving the project and the community within the project in those discussions. It's a big project, lots of areas of specialty. So again, I'm not an expert in all of those areas, but having the people that are involved in the audit, again, gives those project areas a better idea of what they need to focus on. And again, if everybody's working together, overall your security should improve. And that's probably the single key biggest takeaway, is it's refreshing everybody's mind that, yeah, I'll just disable this SSL verification because it'll make this job run a little bit better, or I can't get this to pass in this script. It kind of enforces why you shouldn't be doing those things and reminds people that the quickest, simplest fix is probably not right. And looking ahead, we move on with trying to meet all of those regulatory requirements, ensuring our JDK is the most secure it can be. And we'll see where that takes us. I'm sure at some point we'll do another audit and ensure we've maintained those good practices and fix anything that may get introduced, or things like that. We're constantly evolving. The project is constantly moving forward. Would definitely do it again. And that's pretty much it. So again, you can connect with the project these places. We do welcome contributions from anybody and everybody in any field, let alone security. And if you're keen on reading the blog and our response, they're all available on the Eclipse blog and the Adoptium blogs. So if there's any questions, I'll take those.
Hi, Scott. Thanks. It was a nice presentation. I had a question. This was an audit, like a one-time off thing. You also showed something about process improvements. If you look at the process, you mentioned like some tools like SEMGRAP. Are you incorporating these in your continuous process now, or?
Every PR now gets SEMGRAP run against it to ensure that those list of common things being turned, things like SSL validation being turned off, unpinned GitHub actions, all of those things. HTTP-based downloads is probably the most common one that gets reintroduced. But we have a bunch of other checks, linters and build tests that all run as part of every PR. No PR gets merged unless all of those checks pass. So having a SEMGRAP check there that fails if any of those rules are violated. And SEMGRAP, there are a bunch of community rules. Trail of Bits offer their set of rules that they use for performing the security audit as an open source set of rules. So we implement those into GitHub Actions to ensure that anybody changing code is at least told and gets a big red flag on a GitHub action.
Cool. Thanks.
Anybody else?
Yes, about third-party dependencies, did the audit include also interviews with producers which you receive third-party forms or
Not to the best of my knowledge. It was one of the bits that they validated that we were pulling those dependencies in a safe and secure method, but not necessarily any problems with those projects. I guess if those projects undertake security audits themselves, it would cascade that way. We have other tools for looking at our infrastructure and our containers to ensure that libraries we pull in are what they pretend to be, and that things like CV. I did a talk yesterday. We use a tool called Wazoo, which is basically an SIEM tool, but it has a component called the vulnerability scanner, which actually audits all the libraries of things like the CUPS vulnerability recently was a really good example, whereas they publish the vulnerability and the way to exploit it on the Friday morning, because we've got the tooling in place to validate those things on our infrastructure. It took me about 3 minutes to validate our suite of like 40 build servers, to validate if we'd got CUPS, where we had it, what version it was. And the neat thing in a couple of cases was that you saw the vulnerability be highlighted once the CVE was published. You then saw our routine package update process that ensures all our systems are kept as up to date as can be. And then you saw the vulnerability detector flag it as closed on that system with about 3 minutes effort, which is not bad for 50 servers. So the tooling makes a lot of this possible, and without it, we'd be buried, I feel.
Hi, thanks for the talk. How much focus in the audit was on, let's say, record keeping and being able to demonstrate that the processes were being followed? Because I guess for an open source community, it's kind of, well, you have a large number of contributors from all over the planet. So, yeah, how much was focused on?
We have fairly extensive documentation. So although there's a large number of contributors, only a number of them are active. But again, we communicate as hard and as much as possible. And where possible, we try and enforce good behavior with tooling. But all we can do is talk to each other and try and, again, for the last couple of years, secure development has been the kind of the watchword at the project. And again, we have bi-weekly secure development meetings. It's a key drive. We've contributors from several places, Microsoft and Bloomberg. Daniel has done a couple of presentations at OCX this year around his involvement with our project from Bloomberg's perspective about things like producing vulnerability disclosure reports. Coupled with a bunch of our other secure development practices. Did a talk last year on those, but things like SBOMs, one part of the puzzle, our regulatory demonstration, our SALSA compliance, SSDF compliance, our binary reproducible builds, all of these taken together. I'm sure everybody involved in the project has probably been involved in some of that work at this point. But yeah, to ensure that keeps on going, we just keep talking. We try and encourage everybody to get involved as far as we can. I think that's all we can do. You're all welcome to come and contribute and learn. We always welcome help.
Hello, thanks for the presentation. I wanted to ask which tools do you use in the pull request to validate the security aspect of the pull request, of the submission? So
from a code analysis, SEMgrep and a bunch of linters for the relevant languages across the board. So we have Ansible linters for our Ansible playbooks. regular linting for all our shell and Python, and also linters is probably the single biggest thing. But SEMGREP has become a real key part of that, which is new and only as a result of this audit. From an infrastructure point of view, we use Wazoo, mostly because in a lot of security environments, if you work for a single company, you possibly have control over the entry point into your network and systems. Because the way our infrastructure is provided, so Hetzner, OSU, OSL, Marist, a whole bunch of infrastructure providers, we do not have a single entry point for monitoring and looking for breaches. So we switch. I implemented a host-based intrusion detection system. That tool, having done some evaluation, go and check the other presentation out for a lot more detail, is called Wazoo. It's a fork of OSSEC. Once OSSEC became paidware, somebody forked it. It's still the OSSEC basic log parsing, analysis engine, rule-based detection, but it's got a very nice open search, elk stack technology, reporting bundle stuck on top out of the box. It runs on practically anything. S390X and RISC-V being a little bit more problematic. You have to build the agents from source. It is agent-based, so there is a performance hit. There's an element of log storage size and processing hit. But as a tool, it is invaluable. I say, if you did you catch my presentation yesterday?
No.
No. Worth checking out, but I've one slide, and that talk stemmed from one slide I did last year, which showed the attack surface of our build farm. And the last 30 days, we've had around 30 million attacks on about 30 servers, which gives you an idea of the volume of attack. Anything that's connected to the internet is potentially under. Without the tools to see all of that and validate that none of those things are being problematic, nobody's getting unauthorized access, the tooling makes that possible. If you don't know it's there, you don't know it's happening. And as soon as you do, you go, the scope of the problem. And if you want to talk more about that, I'm happy to demonstrate that tool. It's not one I've got any affiliation with other than an avid user. It's open source and free. All the rules are open source and free. It's a very active community. And if validating any infrastructure, and I say it does other things as well as just log-based scanning. It does have a vulnerability detector. It will score your machines against the various security standards for configuration and offer you the relevant solutions. Where you have package vulnerabilities, it drags in all the CVE scores so you can prioritize fixing them. It will even show you where fixes are available. And again, all of that information helps evolve your management processes across the board as far as package updates and things like that. And I say the CUPS vulnerability is a good example, because as soon as something gets published, the tool is more than capable of giving you that information to see how exposed you are. And in the case of us, most of it was automatically fixed, say for one system that was powered down. So, but again, as soon as we powered it up, we could make sure that we patched that package and cleared that vulnerability, because it's very easy to see.
Thank you.
Anybody else? Right, thank you for coming.